Good evening, sir.
Hello, good evening.
Yeah, good evening, sir. Okay, sir, I think we can start today's class. And yours is joining, I guess.
Okay, Rahulji. Yeah,
Okay, so good evening, everyone. I'm Rahul. I'm Rahul. I'm the online teaching assistant for the course NPTEL online NPTEL course Polymer Reaction Engineering. So this is our 10th session. And in this, we regularly discuss the possible questions that will be helpful for you to perform well in your assignments and the examination. So, as I said, I'm Rahul Dar. I'm a Prime Minister's Fellow from the Department of Physics, IIT Kharagpur, and I'm handling this online session for the NPTEL course Polymer Reaction Engineering. Okay. Okay. Am I audible, sir?
yes, Rahulji. Please go ahead. Yeah.
Yeah. Okay. Fine. So let's start today's. Just a second. Let us start today's questions. So the first one is in bead suspension polymerization. The polymer monomer mixture suspension system may be viewed as an aqueous dispersion of a time-independent viscoelastic fluid. So is it true or a false statement? The main thing to note here is a time-independent viscoelastic fluid. So is this statement correct in case of bead suspension polymerization?
I think it is a dispersion that is definitely correct. It's aqueous dispersion.
Yes. But is
And
it a time independent or time dependent? Or is
okay,
it depending on any other factors?
time independent viscoelastic. I have a doubt on this.
Okay, let us discuss. So it is a false statement. So I think it is a time dependent. It is time dependent viscoelastic.
Okay.
It's actually time dependent viscoelastic fluid. Okay, okay. Then let's move on to the next question. So yeah, dash is used in injection molding. Dash is used in injection molding is manufactured by suspension bead process. So which basically I'm asking for, so what kind of um, what kind of polymer is used in injection molding, which is manufactured by suspension bead process. What polymer is used in injection molding, basically used to fabricate injection molding.
Suspension manufactured by that is actually for injection molding. We do all this uh, polypropylene and polystyrene also is there.
Yeah, polystyrene. In general, we can say plastics, but in specifically, the major one which was discussed in the lecture was polystyrene. Polystyrene. So I guess in general we can call it as I think as you also said it's there are multiple. So in general, I think we can say call it as just plastics. But
Yeah,
yeah,
any granules, whatever we start with injection molding,
yeah,
polymer granules are bead only.
okay. So yeah,
Like if plastics, whatever we use, commodity plastics, the
yeah,
virgin polymers are coming in the form of beads.
okay, 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 fine. So yeah, that is the answer. So polystyrene. according to if we go along with the lectures. So obviously plastic is a broad way of answering this question, but to be specific, it's polystyrene is used as the injection molding and it is manufactured in the process. Okay, fine. So high impact polystyrene and acrylonitrile butadiene styrene copolymer are often prepared in dash process. So what kind of polymerization process is used in the fabrication of high impact polystyrene and acrylonitrile butadiene styrene copolymer?
Generally, injection molding is the one because high impact is means where we have oriented more molecular oriented chains we can generate by
Yeah,
that.
but again, I think if we go into much broader aspect, in the general way it is said as like bulk polymerization or bulk suspension. So
Okay, 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 okay. It's a process. Okay.
yeah, bulk suspension process, or yeah, basically we can say it's bulk suspension process. Basically, I think all these are to be produced in a maybe produced in a bulk amount. So by this bulk suspension polymers, the amount or the quantity at which this can be produced should be much larger. Okay, yeah, okay, fine. In bead suspension polymerization, the final polymer is dash in its own monomer. Like here we are basically talking about its,
Soluble,
yeah,
soluble
it's
is
basically soluble. Basically, we are talking about its solubility, so it is soluble. So that is, I think, it is one of the basic properties of this bulk suspension polymerization itself. Right, sir? Soluble. So the answer to this question is soluble. So in in case of bead suspension polymerization, the final polymer will be soluble in its own monomer. So that is a thing that we should note about this bead suspension polymerization. Okay, so if that's the case, let's move on to our next question. That's soluble. So expandable polystyrene EPS is manufactured by suspension polymerization in presence of dash agent, dissolving agent, blowing agent, heating agent, cooling agent. So which one is basically used in?
it's mostly that foam, what we call polystyrene foam, that is by blowing only.
Yeah, blowing is the answer, which we are also expecting. So it's blowing agent. So blowing agent basically allow this mm, polystyrene, expandable polystyrene to expand. So when heating this blowing agent will generally vaporizes and it creates tiny voids within this polystyrene beads, and that will result in its basically they are lightweight, so it's lightweights and their foamy structure and all is obtained after this blowing when after this blowing agent is brought into the system. So yeah, so blowing agent is the answer.
What we call that thermocols. Thermocols are expanded polystyrene.
Okay, okay. So the okay, so their lightweightness is generally 10. Okay, okay,
Yeah, exactly.
yeah. Okay, someone else has joined. Just a second. Good evening, sir.
Good evening. I'm so sorry. Last class I couldn't able to join.
Yeah, it's okay, sir. Last class, I think there has been so much weather issue here, and in between, I think you just joined, and at that moment itself, the power has failed. Like
Okay,
weather was so worse that day.
okay,
It
okay,
was
okay.
really
Even
thunder and
our
lightning.
March ending also going on. So
Yeah.
during the end of this March, it is very
Okay.
hectic these
Yeah.
days.
Okay.
Today
Okay, sir.
also I anyhow managed to like come early from the office and immediately join.
Okay. Okay. Thank you, sir, for joining. Okay. Okay, so we discussed few questions, sir. I think we can move on. We'll discuss that for question at the end once again. So this is our
Sure,
fifth
sure, no
question. So in
Uh,
BC,
Here we can just complete for completion sake. We can go from the beginning so that we can finish it na, together.
yeah, okay, okay, fine. That is also the trigger. So yeah. So the first question that we discussed was in bead suspension polymerization, the polymer monomer mixture suspension system may be viewed as an aqueous dispersion of time independent viscoelastic fluid. So all the statements given here is true except this term, which is time independent, but because in bead suspension polymer it is actually a time dependent viscoelastic fluid. The viscoelastic property would change as a function of time, so it is not a time independent viscoelastic fluid, it's a time dependent viscoelastic fluid. So the answer to this question is false, and the reason is it's a time dependent viscoelastic fluid. Okay, the next question that we discussed was dash is used in injection molding is manufactured by suspension bead process. So uh, basically in general we can call plastics. So basically plastics are used in injection molding and is used in injection molding is manufactured by bead suspension process. But in specifically, again if we go according to the lectures, it is polystyrene. So polystyrene is used in injection molding is used by the suspension bead process. And the third question we discussed was the high impact polystyrene and acrylonitrile butadiene styrene copolymers are often prepared in dash process, which is basically bulk suspension process. Because basically these materials are processed or these are obtained in a very huge or bulk quantity. So in general, we can say suspension process, or to be specific, it's bulk suspension process. Okay, yeah. And the fourth question was in bead suspension polymerization, the final polymer is soluble in its own monomer. So it is one of the basic characteristics of this bead suspension polymers, and the final product or the final polymer that is obtained is basically soluble in its own monomer. So that is one of the basic characteristics of the bead suspension polymerization. Now yeah, that's now this was our fifth question. So an expandable polystyrene, which is called EPS, is manufactured by suspension polymerization in presence of a dash agent. So it's basically in presence of a blowing agent. So basically blowing agent is a key ingredient, if we can say as so, that allows the EPS to expand basically. So basically when it is heated, this blowing agent will vaporizes, and that would create some tiny voids within this polystyrene beads, and that would result in its lightweight and foamy characteristics of this EPS. As I was mentioning, one of the common uh, example for this EPS system is our thermocol. So the lightweight characteristics and those foamy characteristics of thermocol is obtained because of the presence of this foaming, blowing agent during its fabrication or synthesis process. So that was our fifth question, and again now moving to our sixth question. So if that is clear, we can move on to our sixth question.
Okay. Mm.
Okay, yeah, okay, I'm sorry, moving to sixth question. So, okay, it's sixth question. I think I made some mistake here. Sixth question. VCM suspension polymerization. Uh, the key function of is basically there are two kinds of stabilizers are there in uh, primary in this VCM suspension polymerization. One is the primary stabilizer and the second one is secondary stabilizer. So the first statement states that the primary stabilizers are surface active agents with higher lipophilic content, and the secondary stabilizers are surface active agents that control grain size and also influence the internal grain porosity. So are they correct statements? So are like is primary statement, so is the use of primary statement is like, are they the active agents with high lipophilic content, and secondary stabilizers are the properties of silica to give or to control the grain size and also influence the internal grain porosity. So are they the correct statement? So the first statement one is true, statement two is false, statement one is false, statement two is true, both are true, both are false. Any idea?
Here are actually the secondary stabilizers. I understand that is having the grain size control. Lipophilic only, that word is, I'm not getting the meaning of it. Lipophilic,
Okay.
with higher lipophilic content.
Okay. Any any suggestions from sir? Lipophilic, as the name suggests, like it has to do with some kind of
Lipid
affinity
content, I think.
towards
Lipid,
lipids,
lipid content.
right? Lipophilic is anything that means there is an affinity towards that. So
Yeah, yeah.
lipophilic,
Hydrophilic means affinity towards that. Lipophilic is towards lipids.
yes.
Okay, okay,
So
okay.
VCM is basically vinyl chloride monomer. So in vinyl chloride monomer, when so was basically mentioning about there are in VCM suspension polymers there are two. One is primary stabilizers and secondary
Correct,
stabilizers.
correct. That is
Yeah.
correct. Yeah.
So the answer to this question is actually the both statements are given in the other manner. So in primary stabilizers are the surface activators that control the grain size and it also influences the internal grain porosity, whereas it is the secondary stabilizers that are surface activated with high lipophilic content. So basically
Okay, okay.
here
Both are
both
false.
statements are false. That is the answer, and the correct answer is the correct answer for this is the second one. So this is the correct definition, and for this is the second.
Okay, okay.
Okay,
Clear. Yeah,
yeah.
yeah.
So VCM stands for vinyl chloride monomer. That is basically a process, a polymerization process that is used in the production of PVC or polyvinyl chloride PVC. Okay. So in that process, there are basically two stabilizers are used. One is primary and the other one is secondary. The major use of this primary stabilizer is used to control the grain size and the porosity. The major role of the secondary stabilizer is to uh, they act as surface active agents and they have a high lipophilic content. Okay. Okay, fine. So the value of non-condensable gas in vapor phase side depends on the quality of monomer, vacuum prior to polymerization, generation of inert gas during polymerization, or all of the above.
We are referring to value means the quantity of non-condensable gases, correct? Na?
Yes, yes.
I think it should be if monomer is having some non-condensable,
Yes,
that will be increasing. Vacuum, if we are applying prior to polymerization, we can remove some out the
yes,
non-condensable. And of course, the inert gases again, but I don't know whether inert gases will be generated during polymerization, but
yes,
definitely the inert gases are non-condensable. But let's see about the generation of inert gases during polymerization.
no,
Because generally, polymerization, inert gas purging is there, but use of inert gas during polymerization is okay. But generation of inert gas, I
generation,
have
I
no.
think there is some kind of production of this. So I remember there is some kind of production of nitrogen. Nitrogen is not a net gas, but there's answer to this question is all of the above. So generation of net gas process,
Yeah,
yeah, that is also a true statement for this. Answer to this question is the first one is definitely can be related, and vacuum to pre-polymerization, it is also there should be not gas during polymerization process. Uh,
These all are related
that
to
is
powder
all of the.
suspension
We
polymerization.
have to look for the why this is particular reason, but the answer is all of the above. Yeah, just just see look at this question, and yeah, the answer is all of the above. As I remember, but I
yeah,
don't
yeah.
exactly remember the specific reason for this generation of net gas during the polymers, but I know it is a part of this. Yeah, let us see. So the answer to this question is all of the above. Mm. Now the sixth question, actually it's not the sixth question. I think it's seven or eight, seventh or eight. So okay, anyway,
Sir,
if
can I just ask one thing?
yeah, please, please, please.
Can you go back to the previous question?
Yeah,
Uh, it is actually all related to powder suspension polymerization, where this suspension, the polymerization taking place in a suspended uh, the mixture, where in a vessels this vessels and all the so-called surfactant and all the monomers we add it, and in that process, this water suspension polymerization takes
oh,
place.
so your voice is not that clear.
Hello, now am I audible?
Yeah, yeah, yes, sir.
So actually, all related to powder suspension polymerization. So in this powder suspension polymerization, all the points you are saying, it is the value of non-condensable gases in vapor phase depends on all of the above.
Yeah,
So actually, the points which is given, the quality of the monomer depends on the quality of the monomer vacuum prior to polymerization. So these points, can you just like explain how it is
expand,
related to that?
explain. Okay. So I think definitely the quality of the monomer would play a important role in the polymerization
Definitely,
because yeah,
it will be there. It will be there.
it will be there. And vacuum prior to polymerization because there can be other gases within the system, and that can actually condense it to the system. Suppose there are suppose if there is oxygen in the system, oxygen gas present in the system, definitely that can induce some kind of oxidation in the polymer. So that will again change the kind of or the final product that you want may differ because of this other undesirable gases that are present initially within the system. And option C
Actually,
is
in the vapor phase already, sorry to interrupt.
mm,
In the vapor phase, it is saying there will be definitely gases will be there, which will be which is getting changed. Phase is changed from the liquid to gas.
but if we are going
So
for this vacuum now, basically I think we'll try to suck out all the gases before this polymerization process begins.
the gases will be
Yeah,
sucked out.
yeah. So vacuum. So this is so sir, Sharavan sir, what do you think? Can you give some insight on this?
Yeah, actually, one is like quality. One by one, if we see quality of the monomer,
Mm,
whatever now we are getting to starting material may have a lot of other impurities. Like one part I already explained, like the stabilizers, what they are adding, stationary butyl category type of things. But non-condensable gases depends upon the type of monomer what we use. So there actually, if it is there, the quality is so poor, then non-condensables can form during the polymerization process. And vacuum prior to polymerization, generally we apply vacuum in certain polymerization process to remove these non-condensable gases. If that is not applied, for example, if that vacuum is not applied, we may not be able to remove all this non-condensable, because vacuum is one way where we can remove these volatiles. And next one is the generation of inert gases during year. Only I have a doubt whether inert gas
Yes,
generation
I
they
was
are
also
doing
having.
purging. Purging is one way where you remove all the volatiles, but purging all these materials are non-condensable. When I say volatiles, definitely that is condensable. One way or other, you can condense it and remove it. Here we are specifically talking about non-condensable, which means these vapors cannot condense. Using ambient, maybe cooling tower water or chiller water, we cannot directly condense it, which means that that is existing in gaseous phase, like helium, neon, argon, xenon, krypton. All these things are coming under that category, non-condensables. So, whatever with the current conditions or polymerization, whatever we are generating, that gases which is non-condensables also can be, if it is not properly removed, then all this can increase the load of non-condensables in the vapor side.
So this inert gas will be vacuumed out prior to polymerization. It
Actually,
is
if
generated.
it is that depends upon the type of polymerization, but vacuum application can reduce the inert gas concentration.
yeah,
That is like simply applying the vacuum, we can remove that inert gas that is accompanied anyway by stirring also. If at all any occluded gas is there, that can be removed. That is specifically from the monomer point of view. But again, that depends upon what is the type of monomer what we start. Generally, monomers are coming in gaseous phase also, because ethylene, polyethylene starting raw material is a gas. So like that, butadiene again, butadiene gas, butadiene is a liquefied gas. So like that, different monomers start with that we'll have, but again there also we have to see what is the type of non-condensables sitting inside, which can increase this. Whereas all these three can be contributed, but only thing I have a doubt about this generation of inert gas only, because during polymerization process, generation of inert gas, how it can come. That because polymerization generally happens in say hydrocarbon medium or some area where we will not have any inert gas. Inert gas generally when we say it is all those like helium, neon, kryptons, and
Helium,
all,
yeah.
yeah, those are called as inert gas. So those cannot be generated during polymerization. That is the point.
Is it work as
I
a
just cross-checked
is it
the
work as
answer, but the answer to this question is all of the above itself. But still, I'm having a doubt in the proper explanation for this particular statement. But
Yeah,
yeah, it is a true
if
statement.
it
But
is other way, it can be other way. For example, generation of non-condensables during polymerization is correct.
uh,
The word inert gas only is a problem.
yeah,
is it
okay,
work as a initiator or
No, I don't think so. Initiator also, actually, okay, initiator also, different types of initiators are available. But inert gas generally it is only used for purging purpose. In case when we need any
okay, okay, but
blanketing.
it is saying it is generation. It is saying it is
Yes,
generating
yeah,
generation of
yeah.
inert gas.
So that is
Okay,
doubt.
we purge it.
Yeah, yeah,
It is saying
purging
it
is
is
doubt.
generated.
Exactly, that is the point.
okay, yeah. Let's see this. Let's see this question. I think that the answer is out of the way, but let's see why this is. There is a confusion in this question. Okay, so I think let's move on. Okay, I think the top this one is not changing. It's a mistake. Okay, follow the dynamic evolution of dash in particulate process. A population balance approach is commonly employed. Particle size distribution, pore size distribution, pore volume, none of the above. So we have learned about this population balance approach in this lecture, and this comes from this particular part. And yeah, according to population balance approach, which is the most commonly used quantity or term that is used to understand the dynamic evolution of the polymerization, is the particle size distribution, is the pore size distribution, is the pore volume, or it's none of the above.
Is it particle size distribution?
Yeah, yeah. Answer to this question is particles. So basically, we have seen in the lecture that in this population balance approach, the particle size distribution is generally used to understand the dynamic evolution of the system. Okay, okay, fine. So let's move on. So yeah, so these are different processes in basically yeah, so different processing in formation of this bubbles, or what we say, that is only seen in the polymer. So what is this? So what are these the different process corresponds to? A corresponds to, yeah. Again, this was explained in the lectures. There is this bubble breaking mechanism that was explained in the lecture. So these are the different processes by this
Uh,
bubble breaking can happen. So
can we match A number as 3 through package?
A as the, yeah, it's A as
3 through package.
through.
Yeah.
Is it is it what you said?
Is it like I'm just
No,
saying you
it's
can.
actually A is thorough breakage. is that for thorough goes for thorough breakage.
Second one maybe erosive.
Yeah, second one is erosive.
Second is erosive.
Third one is, so there is a formation of this
D,
liquid film
D
in
I
between.
think second. That is prevented
Mm.
from.
So second one
Yeah.
says is prevented from continuous film, liquid film. So it says that continuous film formation is prevented. So
D is 4, I think.
yeah, D is for
Immediate violations.
immediate coiling and this is C. Okay. So the answer to this question is A goes for 3, B is going for 1, C is going for 2, and D is going for 4. Yeah. Just to note that I think these kind of questions can be asked. These are the basic mechanism of this bubble breaking, and yeah, can be.
During examination, uh, this kind of matching things will become, or there will be
Yeah, anything
options.
can come because you can see similar kinds of questions are also asked in the assignment problems. So whatever they are asking in the assignment, maybe some of the repetitive questions will be also asked for the examination. And as I said, the examination, the questions will be like 80%, it will be much easier, or like as I was explaining in the last class also, as I was saying, basically, there will be a part of the question will be very tough, and only so that only few people can attempt that question. Only people who regularly follows the lectures can actually answer those questions. So mostly the questions would come as per the assignment questions itself, and these kinds of questions are asked in the assignment. So definitely you can expect these kinds of questions in the examination also.
The multiple type
Yeah.
questions, multiple type answers will be there, like A with this 2 or 3, like this A, B, C will be there, right?
Mm. Yes, definitely. Mostly it will be multiple choice questions, and there will be some numerical questions. Maybe that and all depends on the professor you are preparing the questions. But basically, it will be very much similar to the assignment questions itself, and a part of question will be very much tougher, and mostly it will be kind of related to the assignment questions itself. Okay, so let's move on to our next question. Yeah, I think it's a round thing. Yeah, let's move on. The first approaches to modeling the drop breakage process in liquid dispersions were based on Reynolds number, Schmidt's number, Weber number, Froude number. Yeah. So what is that particular quantity where which can be used to model this kind of drop breakage process? Yeah,
Not clear. Maybe Reynolds number is where we are looking for dV rho by mu. That is
yeah. Depends on the
the
flow, what kind of flow.
characteristics of that
Mm.
one. And drop breaking is the what we decide, what we say about surface tension. So it
Yeah.
should have linkage with the surface tension.
So let me discuss it. Basically, it's the Weber number. Weber
Okay.
number is given. So Weber number, as sir said, it is should be related with surface tension. So we can say like Weber number is a dimension as the number name itself. It's a number, so it's a dimensionless quantity, and basically it is a kind of a ratio of some initial forces to the surface tension forces. So if we talk particularly in terms of this drop breakage, we can basically it can actually relate the destructive forces, mm, destructive forces in the sense that can break the uh, drop, and that is basically if there is some kind of flow happening to the liquid, So if once the drop is formed and if the drop can be destroyed if there is the flow of the liquid is larger than the surface tension, right? We have it. If we have a this is a drop and this drop is made of say some X liquid, and this so the flow means it is some kind of a motion that is happening within the liquid, so that is the force due to this flow of this liquid. And if it is larger and larger or whatever it is, basically we can talk about the ratio. So the ratio between this flow force due to this flow and the cohesive force that is actually holding this drop together, that is basically the cohesive drop force that is holding the drop together is the surface tension. So basically the ratio between this flow force and the surface tension is called the Weber number. Okay, so basically if the surface tension, if that value is lesser, then which means that the chance of breaking is lesser, as in denominator it comes the surface tension and the surface tension should be larger than the flow force. And if that is the case, then the drop breakage would not be preferred much, rather that the drop will stay as it is. If Weber number is large, that means there is a higher chance of this drop breakage. Okay, so answer to this question is Weber number. Actually Weber number can be called as the ratio between, so I can write it is as a ratio between surface tension and flow force. Flow force. So W you can get done as the relation system. And we give as the name suggests, it's a number, so definitely it's a dimensionless quantity. Okay, is this clear?
Yeah, clear. Yeah.
Okay, fine. So let's move on. So Weber number is the answer. So the drop will coalesce if the energy of collision is dash than the total drop surface energy, greater than, lesser, equal, less than or equal.
It should be greater.
Hmm? Should be
Be
greater.
high.
Yes.
Greater.
Hmm. Coalescence is basically it is a process by which many things that will come together. Okay. Uh, Energy of collision is greater than the surface energy. Answer is great. Okay. In suspension polymerization process, one can identify dispersed phase, continuous aqueous phase, and gas phase. Dispersed phase can be either homogeneous or heterogeneous, the polarized phase.
Okay, one is a dispersed phase, second one continuous aqueous and gas phase. All three can be there.
The first three, all these can be the answer. Okay, so dispersed phase can be found in a suspension polymerization. Continuous aqueous and gas phase can be found in polymerization. Dispersed phase can either be homogeneous or heterogeneous. That is also true in case of suspension polymerization process. Let's move on. Okay. So here it is given there are two statements are given. Statement 1, if a person wants to prepare high impact polystyrene and acrylonitrile butadiene copolymer using a combined bulk bead suspension polymerization, the water and the dispersion should be added before the phase inversion of the monomer solution. Statement 2, this step of water and dispersion addition is required to suspend the polymerized beads.
Here I have a doubt whether dispersants, whatever we add, that is to be added in the beginning itself to create that phase, right?
Yes, that should be added between also.
And when we say phase inversion, it is the again that solubility factor comes into picture.
Yes, I think so.
Yeah, then first should be the correct because actually it should be added before it
So the
gets.
step would be mm, actually.
Pardon?
I'm also having a bit of doubt in this question. This was
Reversing
again from
means it is
previous
reversing
year
something.
question. So let me say this is from a previous year question, and the prescribed answer was the first statement is false and the second statement is true. This one is false and the statement is true, but I didn't get enough time to analyze the answer why it is in that way. So let us see if a person want to prepare the added before the facing motion.
Here, inversion means what it is meaning. Phase inversion. Inversion. What I uh, find in like what I was searching. It's reversing the things.
Yes,
So here, phase inversion means reversing the phase
facing
of the monomer
motion.
solution.
Let us see. Answer to this question is statement 1 is false and statement 2 is true. So this is from a previous, as I told, this is from previous year question, and this was the prescribed answer to the previous question. So let us specify. Okay, so let's keep this question aside. Um, yeah, let's see why it is. It's just we have to rough out this statement once, and yeah. Okay, so let's try.
The
I'm
answer
also
is
the
answer is C.
answer is C. So this was the prescribed answer from previous year assignment. Pre- Yeah, so answer is C. But yeah, I also didn't get enough time to cross check why it is true. Yeah, okay. So okay. So here there are two statements given. First statement in yeah, there's a spelling mistake. Statement in semi-continuous and continuous immersion polymerization, sufficient free emulsifier is usually required to stabilize the oligoradicals that precipitate in the aqueous phase. Statement 2. In semi-continuous and continuous emulsion polymers, sufficient free emulsion is usually required to saturate the surface of existing interfaces and form macels. So choose the correct option. Choose the correct option. So which one is true? So which one? So what is the basically we are finding the needling down to what is the use of this free emulsifiers. Sufficient and free emulsifier. What is the use of that? Is it used to stabilize the oligoradicals that precipitate in the aqueous phase, or is it used to saturate the surface of existing interfaces and form micelles?
Cells are generally the specific requirement in emulsion.
Mm-hmm.
So emulsifier provides stability to the micelles formed.
Okay.
So addition of free emulsifier will have this saturate the surface of existing interfaces and form micelles. Yeah, statement two, I have means doubt that it should be correct.
No, actually, it's the statement one is correct.
Okay, okay,
Statement one is true, and the second one is a false statement.
okay. Because I still doubt like whether we are talking about emulsifier is like emulsion formalization. missiles, whether that is
Okay,
okay.
no, I was just cross checking. Actually, it is both statements are true. One and two are true statements. So I thought like it just plus. So the statement one is true and the statement two is true. So that is the answer.
Yeah, yeah, because missile is definitely that is
Yeah,
part of
it is
emulsion
missile.
formulation.
Yeah. So yeah, yeah, definitely when we talk about emission, the missile is and also it is used to stabilize the oligoradicals that precipitation that space.
Yeah, clear.
Okay, fine. So in the bait form, the bait form of suspension polymerization, a polymer is dash in its monomer and thus a monomer mixture is dash. So it's soluble, homogeneous, insoluble, homogeneous, insoluble, heterogeneous, soluble, heterogeneous. I think the first part we saw, and in bait, the monomer mixture is homogeneous or heterogeneous. That is a major question. I think.
First, it should be soluble, and second, it should be heterogeneous.
Is it heterogeneous? It should be homogeneous, right?
No, we are telling about first is solubility of the polymer in monomer, correct? Then monomer polymer. Okay, and this monomer polymer mixture.
Yeah,
Okay,
monomer
since it is
polymer.
soluble, then it should be homogeneous. Okay,
Yeah, monomer polymer should be. The answer is A. Okay. So answer to this question is the first one we saw. It should be soluble, and here the monomer polymer mixture is an homogeneous mixture. Homogeneous mixture. Okay. So in VCM suspension polymerization, overhead reflex condenser is used for effective heat removal from polymerization process. By increasing the reflex rate, the porosity and the particle size density of the polymer should dash. Non-condensable gases get trapped in the condenser due to reflex. The trapped gases can dash. So there are two things that we need to know. So any of the four options can be the answers for both of this. So the first one is in VCM, by increasing the reflex rate, the porosity and the particle density of the polymer should can increase, decrease. Basically, these two may correspond to second option. There is no meaning in these two for the first two options. And the trapped gases can reduce heat removal efficiency, or trapped gases can interact with polymers and affect its
condenser.
morphology.
A condenser having trapped gases can reduce the heat removal efficiency.
Yes, definitely.
And first one, when you give the reflex, it again comes back into the medium where already there is a material available. So it is giving another turbulence by reflex by coming back. So only thing I have a doubt that already there is a particle size are there, whether it will impact on that by increasing. Higher the reflex rate means it is not going into the product stream, it is coming back into the reactor. So
Okay.
there only I have a doubt because once we increase the reflect is already like whatever the part of the product is coming back into the reactor.
And also increasing the reflex rate is overhead reflex and so by increasing or decreasing the reflex rate, that will definitely depend on this heat removal process, right? So so slower the reflex rate, I think it means that the heat transfer will be less. Yeah, less if once the reflex rate is enough of enough speed or what I say. If the rate is at enough reflex is at enough rate, then only I think there is a proper exchange of heat within the system. So I think so that is the reason. So and definitely, and that can affect the heat within the system can affect the particle size and porosity. So the answer to this question is it will increase. So increasing the reflex rate should increase the particle size and porosity. The answer
Okay.
here it is increase. Here it is reduce heat removal efficiency. Okay. So the number density function in population balancing modeling is defined by nonlinear integral equation. Which of the following components are specifically involved in the equation? Just read through the question once again. There are multiple parts for this uh, number density function in this population balancing. So what are the factors that it is dependent upon? The idea?
Yeah, this part I'm not very clear.
Yeah, to discuss the answer. So the answer is rate of generation of droplets due to drop breakage, rate of generation of droplets due to coalescence, rate of disappearance of droplets due to decrease in drop breakage, rate of disappearance of droplets due to decrease in coalescence. So these are the answers specifically. So there is a specific function equation that is provided. I don't actually exactly remember the exact that was a long equation. So and there are multiple things in which those equations are related to. So these are the these are the it's not functions. So these are the quantities that it is the number density function that particular integral equation is dependent upon. Just go through the lectures. I think it is very well explained in the lectures. So the next question is, for population balance modeling in suspension polymerization, consider a case where two drops are colliding and a continuous phase liquid is stuck between the two drops. Which stops them from coalescing? The draining For draining the liquid film, the dash energy trigger drop oscillation must be greater than the energy of dash between drop, and the drop link is interrupted until the liquid film is fully drained. So for draining the film, what kind of energy is the kinetic energy of the potential energy trigger that should trigger drop the oscillation, and it should be and that energy should be um, greater than the which adhesion or cohesion energy between the drops. And do you think that?
First one is definitely a kinetic energy.
Yes, first one is correct. It is kinetic energy.
For draining the liquid cream, the kinetic energy of the must be greater than the coercive, adhesive between the drops. Coercion between the drops, coercive behavior. So generally, liquids we draw a similarity to coercion behavior between the
For
drops.
draining liquid majorly to the drop.
Yeah, what we are telling is that it will be like the draining liquid triggered drop, or the energy of triggered drop oscillation must be greater than the
So there is
cohesion. Okay, cohesion means it will my drop will coerce together, coerce and cohesive force.
the adhesion is basically the kind of when two dissimilar particles when they tend to come together, that kind of energy is called
Correct, correct. So it's
here
then
basically it's
definitely yeah.
adhesion should come because one is the drops that we are talking about, one is the liquid film. So I think here it should be adhesion.
Okay, okay.
Yeah. So here once we are talking about this drop and the liquid film. So yeah, to answer definitely the energy that is uh, that will trigger this kind of drop oscillation is definitely its kinetic energy, and that should be greater than the adhesion, because basically here we are talking about two different drops, so they are considered as two different objects, and hence the energy between two dissimilar things are basically the adhesion. So answer to
Just
this
one
question.
thing. Actually, in this question, this liquid film is fully drained. What
Mm.
does that line means? I was
For,
not able to.
for a population balancing model in suspension polymer, consider a case where two drops colliding and continuous space is formed between the two drops, which stops from the collisive. For draining the liquid from liquid film, see, so it is saying that there are two drops, and when they are colliding with each other, they are forming a some kind of. So we see so that in the case where we are dealing with multiple drop breakage process, we saw that, so in that it will form some kind of film in between these two drops. So for that film to drain out, what is the energy that should, so this drop should oscillate in some with a particular energy, and what is the, what kind of energy is it? It's the kinetic energy or potential energy. So that was the first question. So this kind of thing we saw in our previous that question itself. The drops come together. Okay, and when they just collide, there will be some kind of liquid film that will form in between for a particular small duration of time, and that should drain out. And that particular film is stopping them from coalescing of these drops. Coalescing is basically kind of coming together. Okay, kind of mixing.
Here, liquid film is indicating the flame of the drop.
What?
Here, the liquid film, which is mentioned here, is it the flame of the drops?
I didn't. Sorry, your voice is not clear.
Uh,
Yeah, this you are
am I
talking about this
audible?
film, right? Yeah, this film is basically it's a kind of interface. When these two drops collide with each other, at the interface it will form a liquid film, kind of a thin film, kind of a film is formed. So at this particular
Okay.
point, a film.
So, so suppose there is a two drops. There are two drops,
Hmm?
and individual drops having the flames,
Hmm?
and addition
Not
means
individual
attractive
drops, I would say.
force.
I think it is the that collision process at the interface. It forms. I mean, it's not kind of individual thing. That's a.
Here,
It,
interface is the aqueous solution, I
yeah, yeah,
think.
yeah. Interface.
So whenever these two drops
Huh?
get getting close to each other, like there is a addition means there is a attractive force.
Yes.
Okay. So whenever these two drops coming together and getting what you call like nucleated or uh, uh, getting adhesive force,
Hmm.
and in this process the liquid film in between
Yeah.
getting drained
Definitely
out,
for
you
this
mean to
thing
say.
to wash out, the Shen energy should be, see, this is the
Addition,
kinetic
yeah,
energy.
should be
Yeah,
high. Yes,
yeah.
yes,
The
yes,
Shen
yes,
should,
yes.
if there is if the adhesion energy is larger, it will tend to come in contact and it will tend to form this film. But
Exactly.
if the kinetic energy within the drop, the drop kinetic energy of the drop oscillation, which means the smaller particles of this drop, they'll have some kind of kinetic energy, and if that energy is higher, then again that vibrations would stop it from coming in together, and if it is, kinetic energy should be larger than this um, attractive force, which is the adhesion force here. So basically kinetic
Understood.
energy will disturb the system, and that will not allow the formation of, that will just disrupt this formation of this film as it vibrates, and it will kind of destroy the film form, and the adhesion will basically come together, and this coming together will lead to this formation of film. So when this breakage of this film is larger than this adhesion, then definitely that is the, for draining out of this film, definitely the kinetic energy should be larger than the adhesion energy of adhesion. Okay, okay, if that is clear, let's move on. The term thorough breakage and drop breakage process of suspension polymer refers to monomer drop breakage due to high relative velocity difference between monomer droplets and liquid. slowing down of monomer drop covalence due to continuous film formation, monomer drop formation into two droplets and their consecutive deformation into smaller droplets, all of the above. I think this also we saw in the diagram. So if you remember the diagram, I think the diagram was it was like this, and then it will form some kind of a bridge like system. There will be some kind of film like system will come, and then it will break into multiple drops. So this was the representation for this through breakage process. So
Is it the first one, the monomer drop breakage due to high relative velocity
no, I don't think so.
between the monomer droplets and liquids?
So yeah, just uh, so if you are not able to remember everything, just look at this structure. So here we can see say that the monomer drop deforms into drop deformation into two droplets. So this is kind of a deformation happening, and their consecutive deformation to smaller droplets. So I think it is D is the answer. Initially, some kind of deformation will happens to the drop, and
Like how this deformation is taking place, what factor is making it get deformed?
I think it again
There,
comes back to this kinetic energy and those things. I don't exactly remember the process, but
yeah.
yes, the
Like,
steps
but
are.
here in suspension polymerization, we do some kind of uh, uh, hesitation, and uh, the monomer uh, get continuous movements.
Mhm.
So there would be different velocities, and one respect to another would be relative velocities. So from that point of view, actually, I was thinking might be
I don't
because
don't exactly remember the process as such, but yeah, through breakage is this, but I cannot just explain it. But this one is true. So, initially, deformation happens between the droplets and their consecutive deformation into smaller droplets. Yeah, okay. So in suspension polymerization, increase in hold-up fraction of the dispersed phase increases the turbulent intensity. Is it a true statement or is it a false statement? Hmm?
is it true?
We are
Yes,
looking for older fraction, right? That is
yes,
increasing means when turbulent intensity will be less, correct?
yes. It is a true statement. It is a true statement. During a drop coalescence process, in suspension polymerization, the drop will coalesce if the energy of collision is dash than the total surface energy.
I think it is repeating.
Yeah, it
It
is
should,
repeating. It's later. Here's the repeat question. I think the first, yeah, I think this question is particularly taken from the previous year question. So, and the other one that I prepared that from the lecture itself. So definitely the question seems to be matching with the previous year questions.
okay, no issue.
So, what is the characteristics that affects the shear and peel resistance to hydrolysis of immersion polymer copolymer? What is shear and peel resistance to hydrolysis of copolymer composition, molecular weight distribution, chill content, rheology?
Definitely, rheology is one which plays an important factor. Rheology, but shear and peel. Yeah, sure, because rheology only we are relating shear with respect to the viscosity. Yeah, but no doubt resistance to hydrolysis of the polymer. Okay, here we are talking about the hydrolysis, resistance to hydrolysis.
So which one do you think is the answer?
Is it gel content?
Actually, the answer is molecular weight distribution. So basically, a broader molecular weight distribution can lead to some kind of a situation where polymer chains are more easy to shear. So when the molecular weight distribution is higher and the when a part of molecular weight is higher, then definitely that can lead to some kind of shear resistance, right? One part of the molecular part, yeah, one part. So yeah, basically it is the molecular weight distribution. If the distribution is uneven or if distribution is not right, then definitely that can lead to these kinds of shear hydrolysis. So the answer to this question is molecular weight distribution. Yeah, that's it. So what happens if you think it logically also, if if we're having a polymer and the molecular weight distribution is very much uneven, so there will be a part where the molecular weight is low, which means that the in general the bond energy or the total bond strength would be comparatively lesser, and other way the molecular distribution is higher, which means there are multiple bonds that are happening. So if you look into that general way, the total bond strength would be higher in that particular area. So that uneven molecular weight distribution can lead to shear hydrolysis. Okay. Okay, so answer to this question is molecular weight distribution.
Yes, understood.
Dash a free radical polymerization in which monomer or a mixture of monomer is polymerized in aqueous surfactant solution to form polymeric chain. So dash polymerization. Basically, we are talking about what kind of polymerization, which is true, which is the which for which polymerization process is this the correct defining statement. So in in dash polymerization, a free radical polymerization. Dash is a free radical polymerization in which monomer or a mixture of monomers is polymerized in aqueous surfactant to form polymeric chain.
Well,
Yeah, now the question is better for you.
emulsion.
Yeah, definitely. In emulsion, this is P for emulsion polymerization. Emulsion polymerization is a free radical polymerization in which monomer or a mixture of monomers is polymerized in aqueous surfactant solution to form polymeric chain. Yeah. Copolymer composition has direct effect on glass transition temperature of the polymer, which determines the minimum film forming temperature of the latex. So is it true or a false statement? I think sir can give some insight on this question.
No, I'm also not having a clear here. Actually, here we are what we are seeing for film forming capability, because not all the materials can form a film. Uh, because we also have some copolymer with polyamic acid, like that is the one which gets converted into polyimide. That is called Kapton film, right? That is indigenous equivalent to that Kapton what we make, that is having polyamic acid as a resin, which starts from anhydride, BTDA, that is tertiary amine, BTDA anhydride with an amine. So both together forms this polyamic acid. Definitely because that affects the glass transition temperature. And once the what we can say, like higher the TG, then film forming temperature also will be on the higher side. Uh, so generally, the statement is true, but practically speaking, this polemic acid resin is from. But the only doubt on the TG part only I'm having the part effect, because glass transition temperature for polemic acid is thermal stability only is higher. Correct? It is not TG. Thermal stability is higher, but this statement should have definitely is an effect on the film forming temperature. But the composition wise means what way the composition only I'm thinking.
Yeah,
Oh, polymer composition.
definitely the composition can affect the transition temperature, right? So the kind of what kind of polymers are basically added into the system, that will definitely, or basically that will affect the glass transition temperature, right? So like the composition of the polymer, the com the composition of polymer changes. That means the composition of the polymer itself is, the whole polymer is changing. Definitely that would change the glass transition temperature, right? We look into that. Fame from this is a true statement. Can it be
Okay.
looked in that way, sir? Definitely, when the composition changes of a polymer, that will definitely affect the transition temperature, glass transition temperature.
Yeah, generally, the film forming capability, I specifically told now, it is like not all the resins or not all the polymers can be converted into film.
Yes.
Polyethylene also,
Mm-hmm.
LLDP is having more film forming tendency. So like that, whatever composition which is there can affect the TG is correct, and film forming temperature also either it can be on the lower side, because now whatever I told, one polemic acid resin that cannot directly convert it into film, but because of this high viscosity, initial starting this viscosity, you can cast this as a resin over a drum. So then you evaporate the solvent, it gets deposited as a film.
Okay.
Whereas in polyethylene, that is drawn into as a film or blown into film.
Okay.
Like you blow it and convert it into a film. So like different method. Probably I think our Parthaji is in Sipatna. He may be able to give more. They maybe because directly they may be handling this type of system.
So, do you have any practical experience on this particular thing?
Actually, our more into processing through
Okay.
injection molding, blown flame, rotational molding, uh, blow molding, and before that, there's some kind of tooling and design also. Design aspects are there. So, if I like talk about more into polymer, uh, properties and all, and how uh, the phases is changing in terms of so many things. That one actually,
Okay.
I'm not in that into things.
Mm-hmm.
So for that, like how
Okay.
this glass transition TG is
Mm.
like
Yeah. So
affecting
beyond that
things.
particular temperature, basically the material will become much more flexible. So less than that glass temperature, it is the material would be rigid. So what I understand from this question is definitely the copolymer composition will have an effect on the nature of the polymer itself, whether it is like it can. So definitely that will affect the value of the glass transition temperature itself. So as far as I understood, definitely the composition has a very good role in the deciding of this glass transition temperature, and hence the answer is true.
Actually, I was like relating how this minimum film forming temperature is related to TG. Like this minimum film forming temperature, actually, I could not able to uh,
Okay, so
getting things
minimum,
in a.
yeah, minimum field performing temperature, it refers to like the lowest temperature at which latex or it can be basic latex or some kind of adhesive. Will
It's more
it will
into
like
rubber.
yeah,
Mm.
basically it will it's a minimum temperature where it like uniformly collates into like where it will uniformly like spread into some kind of continuous film. Okay, so basically we are talking about and definitely that would be affected by the glass transition temperature, right? So if it is very brittle in nature, then a proper film may not be able to form because we are forming a very thin film. And definitely if the material is flexible in nature, then it there is like a higher chance of forming films of that particular material. If it is like breaking much faster, then formation of these films may not take place, that will break faster. So I think the effect of glass transition temperature will come from that factor, like the like formation, this particular idea of this film formation may not happen if the material is so much brittle. I think it comes from that particular point. Okay, so am I right, sir?
Yeah, yeah. This point is okay. We will go ahead. Yeah.
Yeah. Okay, fine. Okay, then let's move on to the next question. Yeah. Copolymer combustion affects the properties such as resistance to hydrolysis and weatherability. So it's true or false statement? I think we have seen a similar question. Definitely, it's a true statement because previously we have seen how the copolymer composition affects the hydrolysis, that part. Resistance. So definitely, it's a true statement.
Segment, yeah.
Good. Because definitely the composition of the polymers, what kind of polymers are attached, definitely affects the properties such as their resistance to hydrolysis and weatherability. Okay, so that's the case. Let's move on. Conventional free radical polymerization, which is the process used to manufacture almost all commercial emulsion polymerization, dash the production of block and gradient polymers, which uh, so basically it is conventional free radical polymerization is a process which is used. So some there is some uh, there should be some rearrangement. Is a process which is used to manufacture almost all commercial polymerization. That basically allows production of block and gradient polymer, or basically that does not allow production of block and gradient copolymers.
It allow
So does hmm?
allow the production of block.
Yeah, it will definitely allow. It will basically allow the production of block and gradient copolymers. Okay, it says it does not allow. Okay, I also made a mistake. So its answer to this question is does not allow. So conventional free radical polymerization does not allow the production of block and gradient polymers. That is the answer. I'm sorry. B is the answer. I think this is also straight from the lecture. So just you can definitely go through the lecture. So it's does not allow. So that is the answer. So in paper coated with styrene acrylic copolymers, the dry peak strength dash and blister resistant dash as molecular weight of the polymer dash. So dry peak strength, does it increase or decrease? Blister resistance, does it increase or decrease? Or polymer will increase or decrease?
Can you please go back to previous question just once?
Watson,
Can you just go back to previous question? Just previous question.
this one.
Yeah, yeah. Okay, okay. It is like okay.
So which one do you think is the answer? The Does this dry pick strength increases or decreases? And when it increases or decreases, what happens to the blister resistance? And what happens to molecular weight?
The dry brick strength, when we say that is about the
Correct.
production property. Yeah, dry
Yes.
brick strength generally, if it is coated material, then it will be there. And
Yes.
blister resistance also all should be on the higher side, if I am correct.
Not all are on the blister resistance. It actually decreases, and the other two increases. That is the answer.
Okay, correct. Yeah,
Yes.
blister, it should not blister. Correct. Yeah.
Yes.
Generally, when you are coating, it should not blister, but it strength increases, molecular weight also increase. Clear. Yeah.
Yes. Blister resistant basically refers to ability of coating to like um adhere to the substrate. Basically, like it sees how the it just stick, right, form and resist the formation of blisters. So blister resistance should happen. Blisters are like kind of bubble like of thing that will come in the when there is some kind of coating that is being coated over the surface. If there is some kind of bulging or such kind of a thing, so this is basically the blister. So this, and when the peak strength increases, the blister should decrease and molecular weight of the polymer should increase. So the answer to this question is the peak strength should increase, blister should decrease, and the uh, molecular weight should also increase. So these are the answers.
Dry peak here is the dry peak strength is the strength where suppose any kind of
Yeah, yeah,
particular
how
force we
well
are
it is
applying,
like stick
it is
to the,
sustaining the. Yes,
yeah,
yes, yes.
it is well stick.
And
When that
here dry
increases,
and wet is how it is like we are differentiating
what's it?
dry peak. We are how we are differentiating this dry peak
Yeah,
and wet peak.
dry picking and wet picking. What I have to check. That I have to check.
I
I
think
don't know the
it
exact
is
difference.
during the process there will be wet peak, I think, and after the completion of the process it will
Yeah, I
fall
am
like.
also not particularly sure about that. But basically, dry picking is basically the structure strength of this attachment between the, if we say, paint and the surface. And when that is high enough, we can the blister. So basically, I can say this is the reason why we cannot use this varnish and other kinds of paints in metals. So in that, this kind of a blister resistance is large, is not, is like, it is no, that formation of blisters will be much higher. We use normal paints in instead of metallic paints in the metal surfaces. So that again deals with this big strength between that material and the paint. Okay, so answer to this question is option B. So now let's move on. So in adhesive, this is a match the following question. Just check how, what is the correct options for this, correct matching for this question.
Tackiness comes when we have low molecular weight.
Mhm.
So I think air is for 2.
Mhm. A is for true, yes, particularly. Yes, it's true.
Among peel and shear one requires a very high strength, so it should be high molecular weight. So peel is in between, so it should be intermediate.
So B should be, yes, B should be intermediate.
And
And
shear with high molecular weight.
yes, sure is for. Yeah, that's it. So here, basically tag tag refers to the initial adhesive strength that develops as a contact between this adhesive and the substrate. Okay, so tag, it is basically determined, and its maximum is maximum for the low molecular weight. Yield resistance is mainly determined by the intermediate molecular weight, and shear resistance is for high molecular. So this is for low, intermediate, and high. Okay. So which is the correct statement? The availability of acetic acid at the surface. Statement 1 increases the stability of the latex. Statement 2 increases the shear strength of the adhesive. Statement 3 decreases the pitch strength of coated paper.
All the statements are correct.
Hmm?
No. Statement 3 is not
Yes.
correct.
Statement 3 is not correct. So actually it will also increase the pitch strength. Should be increase. It's not decrease. Okay. So the incorrect statement is statement 3. The availability of acetic acid increases all of these properties. Increases stability of the latex. In case of adhesives, it increases the shear strength. In case of this product paper, the pitch strength will be increased. So the correct answer is option 3. So the statement 3. Now, understanding the dash is important during emulsion polymerization, as it panels mixing and heat transfer. It determines the maximum sodium content attainable. It plays a vital role in applications of dispersion, entropy, particle size distribution, rheology, polarization. So which one is the reason for all these three? It panels the mixing and heat transfer. What plays a crucial role? Is the entropy, is the particle size distribution, is the rheology, or is the polarization?
It is particle size distribution only.
Actually, it's entropy. I mean, you actually, it's the rheology is the answer. This is this. Yeah, this
Whether
is.
that is clear,
Huh?
whether that is correct, like particle, when we say maximum solid content attainable, that depends upon the particle size.
But if you again look into the other factors, like it plays a vital role in the application of dispersion, definitely it is the rheology of the particle that will be.
Okay, that way, if we are
And the
think,
panel mixing and heat transfer, again in that case, it is the rheology. So the more suitable one is rheology, I guess.
okay, yeah, because why I'm specifically telling emulsion only will have this, what we can say, powder formation.
Mm-hmm.
Whatever the application, for example, paint, total solid content, when we say, uh, okay, that rheology factor again comes into picture with respect to the viscous behavior.
Mm-hmm.
On shear, how this material behaves.
Yes.
Okay, so paints also it is applicable. Okay,
Mm.
fine, I agree.
Yeah,
Yeah.
I think in general, if you look, rheology will be in better answer. Okay, so let's move on. So dash initiators are used in polymerization carried at high temperature, thermal, redox, cationic, photoinitiators. Yeah, it's an easy question. Definitely, we are dealing with temperature. So these are the thermal
Yeah.
initiators. Yeah. So dash systems are applied for lower temperature and high rate initiation applications. Free radical, cationic, anionic redox.
Okay. Here actually like both ionic. Okay, ionic generally we go with high, what we can say low temperature condition, but
Hmm.
redox I have adopted. Both
Okay.
cationic and anionic generally we can carry out at low temperature.
The answer to this question is basically redox. Redox systems are applied for lower temperature and high temperature initiation
Yeah,
applications.
yeah. So that's why it would be, yeah,
Yeah.
both way it is there.
Both way it is formed, then it is redox.
Yeah.
Yeah. So these are the questions that I prepared for today. Like today it was around 30 questions, and that is what I
Can I
answered.
see that last question?
Last one. Just a second.
Yeah, yeah.
Yeah.
Okay, okay, clear.
Yeah. This statement is directly taken from one of the slide from the slide. So it is the redox system that are generally applied for the lower temperature and high rate initiation applications. Okay. So that these are the questions that I prepared for today. So tomorrow again, next class, I will prepare much more questions. And I think there are two more classes left, and I have also applied for an extra class, one more class. So ideally there will be two more classes, and we'll have one more lecture class. So so in that class, I was thinking of taking some of the important questions, or maybe I will discuss particularly only the previous year assignment questions or something like that. So that will be much more useful from the starting. So it will again be a 2 hour lecture. So that again I comes on the next Monday. It will be our 11th class, and next Tuesday it will be our I mean next Monday is our 12th class. So basically that should be our last class. But again I asked for an additional class on Wednesday. So next Wednesday. So in that class I was thinking that I will take only the previous year assignment questions. So that will give you much more insight into what has already been asked, and so that will give you a better idea for your examinations. So is that okay, or I should prepare general question from
Rahul, when will be the exam?
that part?
Exam
I
will be
don't know.
conducted.
Okay, I don't know exactly. Like I'm not directly connected with the like NPTEL course. So this is a parallel session, so I don't know about that. So that will be definitely
Exam
that will be
for
informed.
exam
But
purpose, shall we need to go some place or it
yeah,
will be
usually
online?
it is like that. A center will be provided, and you are supposed to write the examination at the center.
So I just there is one thing that is hovering in my mind. Like
Mm-hmm.
as I can see in this course,
Mm-hmm.
I can see Savan sir and myself and one more girl
Uh,
who is attending the classes, and I am assuming this 4 person, this 3 person only are there in this course. So exam will be for this three persons only, or more
no,
persons
for
are also there.
examination, like anyone can attend the course, but if you want to get certificate, we have to pay a fee of 1,000 rupees, and then we have to register for the exam.
So
So that
only
part will
three
be
persons have only 3 persons have applied for the
exam.
for the certification.
Okay, then probably only
No,
three of you will write
I'm just
this.
asking actually. As I can see, only 3 person
No,
is
not
attending
necessary.
your class.
It is not necessary that all students should come into this class. Maybe they are studying separately, or maybe even people from industries also will study this. If they want some kind of certification, then definitely they will write the exam. But it doesn't mean they should come on to these lectures. So
So is it like
attendance to
this?
this particular lecture will not be counted at any place. Okay.
Okay, okay. So
So
is it
like
like this? Someone is also taking these lectures. uh, sessions,
Huh?
weekly sessions, like you in other places for other persons,
I didn't get you.
like you are taking these sessions, right?
Yeah,
Right,
yeah,
weekly sessions.
yeah.
So, like you, is there any
There is,
other person taking
there is one
such
more
kind of
guy also
sessions?
taking. Yeah, he is also taking one lecture. I think he is
No, no,
taking
for
which
other
is
person, for other person, for not for us.
not for I. There are two sessions that are running parallelly. One is mine, and there is another session. I think it is on Tuesday.
Yeah, yeah,
So
Tuesday.
maybe some
So,
students are regularly attending on that session that I don't know. I haven't entered to that particular session.
other than these two sessions,
No, no, nothing
2 day
else.
session,
No,
that is
just
what I'm
the
asking.
only these two sessions are there. There are two sessions for polymer reaction engineering course. One is on Monday, and I am handling that. There is another session that is, I think it is happening on Tuesday or Wednesday, and that is happening by another TA. So I don't know how many students are entering to that class. So around similar number of students are entering. Two to four
Yeah,
students are entering to.
same number only.
Yeah.
Me and Savan sir only, we two
Okay.
person only continuously attending.
Okay.
No other person I get to see actually, to be
Okay.
honest.
I don't know. Like people definitely can uh, do well in exam even without attending any of these lectures. So, but the thing is that you should pay, like there is an examination fee and certification fee of 5,000 rupees, and that has to be paid, and they will prescribe you one particular center. I think it will be, I don't know. At IIT Kharagpur, I used to see there is examination center at IIT Kharagpur, but I don't know what is how it is distributed and all that I don't know. And they will give you a particular examination center, and then you have to go to that examination center and write the exam.
Okay, Rahulji. Anyway, thanks for this sessions. But probably we will, as you told, we will have that one last session also for that entire assignment together. So that will be really helpful to
Yeah,
us.
yeah. I also
Like,
thought that that
yeah,
will be a better
definitely
way.
that will be
Instead
helpful.
of me
We'll
giving
go
some
back.
random questions at that point, it is better that
Yes, yeah, yeah.
if you are able to analyze some previous year questions, then that would be much more helpful.
Fine. Yeah,
Yeah, that would
that
be
will be
good.
really
Yes.
helpful. Yeah, thank you very
Yeah,
much. Shall I take leave?
yeah, sure, please.
Tomorrow morning,
Thank
early
you.
morning, I am leaving. That's why. For
Okay,
one.
please.
Yeah.
Okay,
Thank you
okay
very
then.
much.
Okay then.
Thank you,
Thank you so much.
Rahulji.
Yeah, thank you so much
Thank you,
regularly
thank you so
attending the
much.
class.
Uh,
Thank you.
Thank you,
Thank you,
thank you,
Rahul and
Okay.
Parthaji.
Okay.
thank you, thank you, sir.